what happens for r goes to infinity? Well, for r goes to infinity, you also have to be a little careful what you assume. It's not, you know, I wish I could tell you it's always like this, but it's not. It's rich. There are all kinds of problems. So there's two cases where there's an analysis that is simple. Suppose v of r is equal to 0 for r greater than some r naught. Or r times v of r goes to 0 as r goes to infinity. Two possibilities. The potential is plain 0 after some distance, or the potential multiplied by r goes to 0 as r goes to infinity. And you would say, look, you've missed the most important case. The hydrogen atom, the potential is 1 over r. R times v of r doesn't go to 0. And indeed, what I'm going to write here doesn't quite apply to the wave functions of the hydrogen atom. They're a little unusual. The potential of the hydrogen atom is felt quite far away. So nevertheless, if you have these conditions, we can ignore the potential as we go far away, and we'll consider the following situation. Yeah. Look that the centrifugal barrier satisfies this as well. So the full effective potential satisfies this. If v of r satisfies that, r times 1 over r squared of the effective potential also satisfies that. So we can ignore all the potential, and we're left ignore v effective, and therefore we're left with minus h squared over 2m d second UEL dr squared is equal to E UEL. And that's a very trivial equation. Here, it's interesting to consider two possibilities. The case when E is less than 0, or the case when E is greater than 0. So scattering solutions or bound state solutions. For these ones, if the energy is less than 0 and there's no potential, you're in the forbidden zone far away, so you must have a decaying exponential. EL goes like exponential of minus square root of 2me over h squared r. That solves that equation. You see, the solution of these things are either exponential decays or exponential growths and oscillatory solutions, sines or cosines, or e to the I things. So here we have a decay because you're with energy less than 0 and the potential is 0, so you're in a forbidden region, so you must decay like that. In the hydrogen atom, what happens is that there's a power of r multiplying here, like r to the n or r to the k or something like that. If E is less than 0, you have UE equal exponential of plus minus ikx, kr, I'm sorry, where k is square root of 2me over h squared. And those, again, solve that equation, and they are the sort of wave solutions far away. Now, with this information, the behavior of the U's near the origin, the behavior of the U's far away, you can then make qualitative plots of how solutions would look. At the origin, they grow up like R to the L. Then it's a one-dimensional potential, so they oscillate maybe, but then decay exponentially. And the kind of thing you used to do in 804 of plotting how things look, it's feasible at this stage.